Hey there, thanks for tuning in and welcome to another Ellipsis Drive podcast. Here we dive into the stories of people, companies, and technologies that transform and empower the spatial data-driven industries. My name is Rosalie van der Maas, and today we'll dig into the topic of data sovereignty in the geospatial space. We'll be doing so with my guest, Michal Bylicki. Michal is the account manager, or the account management director, I should say, at CloudFerro for over 7 years now, and he has helped the business to grow into the cloud platform that it is today. Welcome, it's great to have you.
Hello, thanks for having me.
Sure thing, the pleasure is all mine. So CloudFerro as a business positions itself as the sovereign European cloud for space and beyond. What should I take this to mean?
This is a very good question. What does the sovereignty mean? To me, sovereignty means that I have full control and the final authority over my, that's called technological stack. So it's not only about where the data sits or where to put my hardware, if we are talking about the equipment, but it's about maintaining control over the entire operational chain or technological stack. So it is infrastructure, compute storage, software, APIs, security layers, and so on. And then now also AI capabilities. It's all connected to the sovereignty topic. As we are a European cloud provider and we focus on we have a little bit, let's say, European understanding of this topic. So in this European context, it means that institutions, companies, governments can access, process, and store EU data or any other data without strategic dependence on non-European stakeholders. So I would say this means being a sovereign operator. And maybe one more thing, it's like it's an intersection of technological and policy issue, because on the political side we have the regulatory side and discussion, who controls the data, which regulations apply, who can access the strategic data set and strategic assets, and what are the compliance requirements. But policy alone is not enough, because if infrastructure beneath is externally dependent, such as, I don't know, compute, cloud, and so on, if it's all controlled outside Europe, then this technological sovereignty, or then the sovereignty itself is theoretical and not operational. So that's where we come in and propose an alternative to the major players that is fully European and not dependent on the external providers. So for us, it's like having the control over full technological stock, whenever possible, rely on open source solutions, and be open in a sense of interoperability and readiness to cooperate with other players. But the control, I think, is the key here.
Makes sense. Makes sense. So related to the interoperability point that you're making, like when we just look at data sovereignty as a concept, and I understand it is indeed about the principle of ensuring that you have control over data, including its hosting location, its creation, its processing, etc. Like that concept in and of itself sounds to be sensitive to siloing, but what you're saying is that the strategy that you guys are employing is to be very consciously interoperable with other European players. Could you talk a little bit about where you may encounter some friction there, or whether the friction isn't there entirely, and I'm wrong in assuming that yeah, striving for sovereignty can also sort of entrap you into silos.
Yeah. So I think this is the very important issue that we are, let's say, all discussing. And the one quote that stands is that security without interoperability, or sovereignty without interoperability, is an isolation. And I think it very well defines what we are struggling here. So it's not we are not aiming at having a lot of independent solution that cannot interact between each other. So if it's designed properly, the sovereignty should enable trusted collaboration between different stakeholders and institutions. And it is especially important in the Earth observation ecosystem, because value of EU data comes from combining different data sources from different institutions, from different domains, maybe with another specific domain specific algorithms. They are used in climate monitoring, disaster responses, agriculture, security applications. All of them basically require some kind of interoperability and shared access to very large data set. And this is where we came in with the, for instance, Copernicus Data Space ecosystem that is built on the idea that we have the one of the biggest open Earth observation data repositories in the world that are accessible for everyone at no cost. It's financed by European Commission and managed technically by European Space Agency. Yes, but it's done in a way that anyone can use it and run their processing on top. And I mean, it's not so obvious how to manage this kind of data repository. There are hundreds of different data sets with different data formats. Everything is evolving quickly. So there is a again mix of institutional regulatory approach how to make this data available, and then technological problems behind making these data sets available. So maybe to structure it a bit, the data set itself there need to be, and the solutions that needs to be built around the shared standards. So I think this is very important that we have some standards, hopefully, or as much as possible the open one, like we use stack catalog for making the data available. And once it's adopted and open source and everyone can use it, it's quite easier between different platforms to interact and to use the same technical or to talk to each other, let's say, through the standard interfaces. And also it's easier if we have same formats of data. It's easier for users to switch from one data set to another data set with similar processing algorithms. And the concept of federated infrastructure, it can mean a few things, but basically there is no need to rebuild big repositories for each platform independently. When we have a big data set that is stored in one place, it is important that user from different platform, from different ecosystem can access this data set without the need to replicating everything that has been done somewhere else. So this is kind of a federation that allows you, if we have the same standards and the defined rules of accessing the data across different platforms, then we can make other exchange of this data on the need basis rather than to create an application of effort. So this is I think more or less. Maybe one more thing that I would add as a, let's say, illustrative example to be a bit more specific is that once we operate, this is the rule that we do in the Copernicus Data Space ecosystem, that all the data are here and they are available. But there are several national and international platforms that use Copernicus data, and they are built on top, meaning that they can access all the Copernicus data, but they have some specific data set, their specific services built on top, using some kind of federation, either of data, sometimes it's even identity federation. But 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 basically the key is that we build a service on top of the existing one, the Copernicus data space ecosystem. We built another service that use this data set, but as a user, not as a, let's say, try kind of a replicator.
That makes sense. So basically, and this is a very short recap to a thorough explanation. But basically, what it comes down to is your note of sovereignty without interoperability becomes isolation. So interoperability needs to be taken very seriously. It's the key to everything. In order to achieve interoperability, federation is very important, like understanding each other's standards, making sure everything interconnects, avoiding data duplication, because then you're just doing the same trick over and over and over again. Um, My question there is, how does federation differ from centralization? Because you hear oftentimes many corporations and in some cases national governments striving for centralization, and then others making a point for no, actually federation is better. Can you describe to me the key differences between federation and centralization, and why you would opt for federation in the European context?
In European context, it's pretty simple. I think there's no other way than than federalization because of the how Europe is constructed. So we have multiple stakeholders and multiple entities that are using. Let's use the example of observation data. Yes, but they have their own. There are countries that are running own constellations, and they each country want to have a separate independent constellation. At the same time, they are cooperating quite closely. So in order for them to, let's say, benefit, so it's mutually beneficial if they can share the data that they are acquiring. So when two countries have separate constellation, they if they are federated, they can share the data. So the one country can share this data set with the second one whenever needed. And it's especially important, especially useful when they're, for instance, different type of sensors. They are sometimes radar data versus optical data, so they can share um, different capabilities. But sometimes it's also about the temporal span, so they can share the data over some area at the moment when there was no acquisition from the first constellation. So this is like the why I think this is the only way that we can do it in Europe. But it has some other advantages. So the advantage is that it is a little bit more robust in a sense that it's the federated system or the ecosystems are much more robust than the central one, because the central one is central, so it can be, let's say, vulnerable in this sense. The federated one usually does not have one weak spot. But I mean, this there's an also it's also again quite a nice thing when the kind of a central can be complemented by a federated dataset. So even if we have some kind of a central ecosystem, so or let's say central, how would you say call it, data database, central point of accessing the data, it still can be complemented by another sources. And I mean, there is one more thing. There are too many data sources to work in a centralized way. So when we I showed this on this example of several countries having several constellations, but when we add to this, I don't know, drones operators, and then we add IoT devices or some in situ data and so on, having it decentralized in a sense that you can get the data from different sources, ideally store it in different locations. Some users want to have completely private data store. Some users want to have it located in public cloud. So it's getting it much more feasible.
So in that sense, if we take a step back, for a national government to want some sort of centralized solution, it makes sense. But at the same time, in order to properly collaborate with other national governments, federation is key. That's
Mm.
where you find strength and robustness. And you also understand that initiatives like the Copernicus Data Space ecosystem, you can say, well, that's a centralized repository because you're storing the data once for a host of downstream users, but at the same time, it's a federated system because it easily connects with other data sources. Because you're saying, like, yeah, there are simply too many to want to centralize. So at the end of the day, you're going to have to play the federated game.
Yeah. I mean, and this is very difficult differentiation between centralized and decentralized, because one system can be at the same time, let's say, central national repository, and be a part of federated European ecosystem. Yes.
Yeah, it depends on the scale at which you look at things.
Or you mentioned the Copernicus Data Space ecosystem. It's centralized repository for Copernicus data, which is by architectural structure decentralized from the beginning. Yes, because it's located on different clouds in different cloud regions in different countries. Even the EO data is distributed. I would say the catalog is central here. So this is the maybe this central part. At the same time, it's also quite useful if you have this kind of a trusted central repository. I've recently come across the story of I think it was published by Washington Post quite recently, that they, use the Copernicus data as a source of validation of other commercial sites. So if you have kind of a public authority that can provide a trusted data set that can be used for verification of other constellations, it's also a very interesting concept. It's a bit a side topic to what we are discussing today, yes, but only a bit.
I think it's quite interesting what you're saying, like, because I said, like, hey, in essence, the Copernicus Data Space ecosystem feels like a centralized solution because it's one place where you can go in to gain access to a very large archive of data. But that's really just the user point of view. When you look at the way it's actually organized, it's decentralized. But I think that speaks to the experience of the system.
Yes, and also we are onboarding a lot of new data sets, and it's done in a different manner depending on the needs and the needs of the, let's say, data provider or stakeholder. So we had a long discussion how to do this, but basically you can do several layers of federation. So one is the identity itself, which is the straightforward. Then is the data catalog. So you just pull the metadata of the products or push them into the catalog and publish to the user, but you don't provide all the data itself. Then you can also add the data itself to the, let's call it CDSE repository. So you make it available for the user immediately from the interfaces there. But there's also an option that you don't provide the data on site, but you let's say redirect user to some other place where she can get the data from. And also one more thing, there is also the very strong requirements for the access control. So even if you publish the data there, still the data publisher wants to have kind of a control who can access the data. I mean, sometimes they are open, or most often in our case, they are open the data. They are the open data, but there are cases where you need to manage that this product can be accessed by the user with specific privileges or accept with their specific role that is accepted by the data provider. So it's a quite a broad and not an easy task to fulfill. But federation is there definitely.
There's a lot of technical depth
And
to how to do this and how to do this
yes,
well.
and one last complexity to add, you can also think about, adding the processing pipelines on top of the data. Yes, so you add
Mhm.
the service that use the data to process them. So I don't know, we have the users who use Copernicus data massively to do the agriculture monitoring or to do the flood monitorings in terms of some kind of natural hazards and risk monitoring. Yes, and they build their service on top of the Copernicus ecosystem, and sometimes they want to use the user base there to publish their capacities and skills to promote a bit the solution. But anyway, this is kind of a federation that is it's very broad, and I think we see from the number of use cases that or number of applications that use Copernicus data that this is it is happening sometimes from the bottom from bottom to top.
Mhm. Yeah, I understand it's something that has a lot of merit, and in a sense, you can't sidestep it, the need to federate, but it can also create um, some technical bottlenecks that need solving. On that topic, earlier this year, CloudFerro led a project called Endure, Could you perhaps give a bit of background on this particular project and reflect on whether that particular project has managed to demonstrate like a leap forward in demolishing some roadblocks towards full sovereignty and effective federation?
Mm-hmm. Yeah, so this is a very interesting topic, and Endure is I would say it's a platform that uses your data for monitoring vast areas in a systematic and continuous manner. So it can be used for any crisis situation, including dual use situation, and basically it can be used for instance, for infrastructure monitoring, borderline monitoring, but also natural risks or some kind of a damage assessment. It is fully European initiative, and I would call it fully sovereign in this context. It utilizes sovereign EU value chain from satellite acquisition through the cloud infrastructure and HPC that is installed, through the processing chains and processors, all the way to operational services like I mentioned, like change anomaly detection, change detection with use of artificial intelligence to give user the insight about what is happening on the ground. And also it really provides the functionalities for the end users to visualize what is happening on the area, to spot the anomaly as soon as it appears, and then give them, let's say, chance to react quicker to any kind of such an anomaly. And also then some capacities to run the post process the data, to run some kind of processing on top to get a better knowledge on what is happening on the ground. It was kind of a demonstrator, so it was not yet or it is not yet a full operational platform, but the functionalities that it demonstrated were very nice, and it showed that you're able to do a systematic acquisition of we use also Copernicus data for this demonstration, but basically it's systematic acquisition of any EO data on which you process and spot any kind of anomaly immediately as it appears, and then based on that you give the decision maker chance to react quickly on what is happening. And it used European satellite, it used European ground segment, European cloud infrastructure, European processing environments, and a European controlled downstream delivery. So and we work on that together, which was a very nice opportunity to work with you on this topic as well. So I would say in this context that's there's no technical constraints that would limit us from selecting a sovereign provider. It's about the decision makers to be ready to make such a decisions, because the truly very advanced and well working systems are there. They are operational on big scale. They are very good, but yeah, it's only about the decision makers to be bold and use them.
Makes sense. Yeah, and I think that's a very fair call to action to make because it does take some boldness to stray from maybe the usual suspects when it comes to cloud infrastructure and, for example, AI use. But I think it's great that this project and just CloudFerro's general operations show that European sovereignty is very much within reach, if not already operational in some distinct cases. So yeah, that investing in that road makes sense, and yeah,
Yeah,
promises a good sovereign future that is
yeah. I mean,
technologically valid.
yeah. I mean, maybe I will ruin this one nice, let's say, summary, but basically, this is how CloudFerro started more or less 11 years ago, from building a demo of a system for Earth observation data when first Sentinel has been sent to orbit, and there a need appealed to to publish the data, not necessarily as a just the data, but also to give users some capacities really use the data. And so this is where we started our adventure with geospatial and Earth observation market. Yes, and after these 10 years, we have become the technical operator of Copernicus Data Space ecosystem. We are part of Destination Earth initiative, and so on. We are member of consortium who built the Wikio platform. We are building national platforms for for DLR, Code DE, for Polish Space Agency, ANSYS Cloud, and a few others. And we are also one of the leading European cloud operators, sovereign cloud operators, I would say. So I think this means that, I mean, there is from this kind of a projects that are, start as a proof of concept, and they are come from the needs to have some kind of an attractive and sovereign systems, the really greater economical good can come into realization. I mean,
For sure, for sure. And even though your footprint is already quite large, it can always grow bigger, and then that would be a good thing.
yeah, I mean, hopefully.
Great. Awesome. So, with that, we are at time. So, Michal, thank you so much for sharing. And for those tuning in who'd like to know more, we'll leave some links in the description so you can find what you're looking for. Thanks for being with us today. And until the next one, cheers.
Thank you.